Now let's talk about correction factors a second. You know, what's the difference between a correction factor and a performance factor? One way that I would sum it up is saying your performance factor is your internal performance of which your company has historical data upon how those systems were put in. So for instance, with on a carbon steel welded system, whether you're running chilled water through it or heating water or compressed air, it's still a carbon steel welded system. Your company knows what type of a multiplier to use off of MCA rate, MCA labor units, to get it to what a real life installation, a normal installation would be for your particular company. So that's what a productivity factor would be. So I'm doing carbon steel welded, and I've got my average crew, it's a B crew. What is my productivity a factor that I'm going to use? A correction factor would be, this thing is running at 20 foot high in the ceiling, I need to correct for height. As soon as I poke out the wall and I get out on a rack, I'm still 20 foot high, but I'm running it in the winter time. Not only am I high, I got a winter condition. So those are correction factors that you would apply at the line item detail as the item is being taken off, while that particular condition exists. And then you get into the next area, you might have other factors on it as it goes through that pipe wanders on through the next area. So that's how you would do your correction factors as opposed to a performance factor. Now, performance factor, we typically will look at those like at a system level. So we're on a carbon steel butt weld system, and for everything I'm taking off that applies to that system, I'm going to use a multiplier, say like 0.75 MCA as an example, and then at the line item detail, whenever it needs to be corrected for height or weather or any of those items, we'd be applying a correction factor at that point. So is that pretty clear on the difference between the two?
Maybe the most common question that our committee gets is, what factor should I apply to this system? I haven't installed it before. And we don't have an answer for that question. I mean, it's the most commonly asked question, and it's the one we can't answer because it's all specific to your company. So we can tell people or show them how to apply the correction factors and what the basic assumptions are. And beyond that, we really can't help people. We get that question a lot, though.
And even geographical area would take would come into play with that. So take a performance factor that you would use here in Kansas City. If you were to be in the downtown core of Kansas City, that same job, downtown core, versus doing that job in one of the outer areas of Kansas City, would you apply the same productivity factor on it? No. Downtown, working in the downtown core area, it's harder to get material on the floors and everything, right? So that productivity factor, even in the same job within a geographical area, would be different. You take that same job in downtown Kansas City and you go do it in downtown New York. Are you going to use the same productivity factor? No. So that productivity factor, you know, is not only on the difficulty of the job, the system that you're doing, but it can also be the geographical area in which you're performing that work. So that's kind of a segue into the next one. I guess I gave a little bit of it away. So let's think about things that affect your job's productivity. So there's company productivity and there's job productivity. So there's things that affect both sides of that. So this particular slide talks about some of the things that affect your job's productivity. So think about, you know, geographically, where is it located? So, you know, whether it's in the downtown core, it's in some outskirts of the Kansas City area. The labor availability for that particular job site will affect it. Logistics to the job site, where's your laydown area? I was in Las Vegas not too long ago, and when they were building on the Aladdin, I saw where the laydown area was for the Aladdin, and it was about a half a mile away from the actual job site itself, and just trailer after trailer after trailer. So imagine trying to get your material over and get it staged ready to go up. So that laydown area, the logistics to the job site is just really important. Customer requirements or relations, that's really an important feature or item that would affect your job site's productivity. Adverse weather or temperature, your crew or schedule or crew size, design completeness and the complexity of the job, stacking of trades, morale and attitude, reassignment of manpower, crew size inefficiencies, dilution of supervision. All of these things really affect the productivity on that job site. Some other ones that we have listed here is a learning curve, fatigue and overtime, weekly job site meetings, magnitude of change orders, high absenteeism and turnover, inadequate lighting, material shortages, jurisdictional disputes, high accident rates, availability of skilled labor, and uncontrolled breaks, early quits for lunches, late starts, those types of things. All of those really affect your job's productivity.
There's actually a link to a number of management methods bulletins. So the MCAA management methods bulletins, some of those are directly relevant to what we're talking about, and there's 2 documents in management methods that are specific to identifying and maintaining your labor productivity on job sites. This bulletin is Bulletin PD1, which is on here, which is, as you can see, a lot of narrative on the things to be tracking, and then some examples on how to track and manage your productivity. The other document that's listed on here is PD2, and this one actually goes into detail on very specific ways of addressing certain things that affect productivity. So people have seen these when they've worked on some of the cumulative impacts of change orders, refers to some of these items. But there are links to these documents on the WebLM, and a really good reference tool for everybody to see that, you know, talks about different ways to be looking at what kind of impacts these various items could have. So MCA's really created some nice resources for people to use related to this.
Next, let's talk about things that affect the company's productivity. So we talked about the job site. So now what affects your company's productivity? So when we say that for a carbon steel butt weld system, you know, we normally would use like a 0.75 multiplier. Well, what also affect how we come up with that particular number? Okay, so some of these things, these are all things that apply with your productivity within your company. So what type of a project management system you use, so you know you might be using CGC or whatever you're using for the control of your project management system. Pre-planning process, handoff, post-job review. Does everybody does some type of a handoff on your jobs. I mean, whether it's just you got a very simple estimate, you still have to tell the foreman what you estimated, right? But for a really complex job, do you have a formal process in which you do this handover on to your craft? I see some heads nodding yes. You know, one of the things that we did was we had actually three different criteria, because at the company that I was working for, Gem Industrial in Toledo, before I went to Trimble. We were a multi-trade contractor, so we had all specialty crafts in-house. So our 3 criteria to whether we were having a pre-job meeting or post-job meeting was, one, that it was $100,000 in value or more. We'd have a formal sit-down pre-job meeting. If it was a shutdown, meaning any type of a job that was going to be a shutdown, had a pre-job meeting, and then any job that represented more than one craft. So it was the electricians and the pipe fitters. That way, you know, we don't all talk. This will make us talk, right? So we'd have a formal pre-job meeting, and post-jobs afterwards, those same people would attend. And generally, the people that would attend that, obviously the guy that, the estimator that estimated the project, who the project manager was, the foreman, we'd have somebody from the trucking department there, somebody out of the tool room, finance on the accounting side of it. So representing every one of the different departments that were going to get touched by this particular job. So that's what that particular pre-planning or process was. And you know, I'd encourage you, if you don't have something like that, to try to get something put in place like that, just for that turnover of information. Safety policies of your company, company expertise, condition and age of the tools, the company's culture or motivation level, the geographical location of it. The uses of your fab shop is really big, you know, and more fab shops are being pushed to the limits to get more creative and to come up with other ways to deliver that fabrication to the job. And then training, you know, so same thing with having pre-jobs and post-jobs. Training was also a very big thing within our company. We did once a month trainings for both project management. This morning I attended a safety training meeting. Those types of things are all real important to get information over to all of the craft. And I'd encourage, you know, if you don't do that, to have something put in place along that lines for those handoffs. So those are some of the things that affect your company's productivity. Then labor, we talked about factoring for abnormal installation conditions such as, if it's cold weather or hazardous working areas, working heights above or below grade. So the LIM says that if you're deeper than 4 foot in the ground in a trench, you're going to apply a correction factor for being too deep. So get your correction factors applied. Your shop prefabrication, so obviously this is where you're going to be gaining hours, if you will, or cutting hours out of your estimate because you're using your fab shop, right? So not only are there areas that you need to add labor for height or for weather conditions, there are areas that you could actually cut labor. So using fab shop would be one, repetitive conditions or repetitive operations would be another. So the more times you go and put that toilet in or whatever that item is, the more of them you had to do, the quicker the guy should be at putting it in. Okay, then there are some correction factors that are in the WebLIM. At the very top, you have correction factors. Okay, so this is another document that I would encourage you to go back and read. And what it does is it will give a topic. If the piping's to be installed between 10 feet and 20 feet, you're supposed to add 1 to 2% for every additional foot above 10 feet. Now, Jim, we didn't do that. What we did, we said our basic assumptions are if it's below 20 feet, we don't need to factor it. That was our basic assumption, right? But that's the assumption that the WebLIM was predicated on, and I would encourage you to go back and read these. There's a couple pages of them here. It just goes right on down through there, and then so it gives you the topic on the left, and then the suggested factor on the right to apply to it. Stacking of trades and crew size inefficiencies, working second shift, they call it swing shift or graveyard. So working second shift is an adder of 20%. If you're working third shift, an adder of 30%. Within your own company, you can figure out how to make those different situations apply. Like we're running a third shift, we'd make it a weld out shift only. That way they're not asking questions so that you wouldn't have 30% inefficiency on that shift. So there's some things there you can do to help with those inefficiencies, if you will.